interesting and challenging problem. The problem is if x square plus y square plus xy equals to 0, find x minus y upon x raised to the power of 80 plus x minus y upon y raised to the power of 80. You have to find the value of this expression. Fine. If you think you can do it, then pause the video and try it yourself. Otherwise, let us solve it together. It's going to be a very interesting. Let's see. Solution. We are given x square plus y square. This I will write as minus 2xy plus thrice xy equals to 0. In order to make this a perfect square. So that now this expression for me becomes x minus y whole square is equal to minus 3xy. This value we shall be using here. And also from the given expression, I can write x square plus y square is equal to minus xy. Fine. These are the two important results which we get from the given part, and we shall be using it further while solving the expression. Now we have the expression x minus y, this to the power of x whole raised to the power of 80. I'll write it as square, and this raised to the power of 40, and this is to the power of 80 plus. Same way, I'll write this expression as x minus y whole square to the power of 40 upon y to the power of 80. Now I will replace this part by minus 3xy, which we have just found out. So this is minus 3xy raised to the power of 40 upon x raised to the power of 80 plus minus 3xy raised to the power of 40 upon y to the power of 80. Now let me simplify this further, and this becomes even power. So this negative sign will go. It will become 3 to the power of 40. Let me take it common. We are left here with y upon x raised to the power of 40, because x raised to the power of 40 and x raised to the power of 80 will cancel, giving x to the power of 40, and this term will reduce to x upon y raised to the power of 40. So here one very important substitution will work. Usually, let me put y upon x say as alpha. Automatically it will strike that x upon y should be 1 by alpha. But that leads the problem to a very blind end. So after giving a thorough thought, let us put it x upon y as beta. And now let me find out alpha plus beta, which is nothing but y upon x plus x upon y. It is x square plus y square upon xy. And we know that x square plus y square from the given we have is minus xy. This is minus xy upon xy. So ultimately I get alpha plus beta as minus 1. This is an important result. We shall be using it because this cancels and it gives us minus 1. And let me find out the product. Alpha into beta is also 1. Y by x times x by y is again 1. Now let us write a quadratic equation in, say, some variable t whose roots are alpha and beta. So that is going to be t square minus the sum, that is plus t, plus the product 1. This is the quadratic equation whose roots are alpha beta. Okay. Now let me multiply both the sides by t minus 1 into t square plus t plus 1. My intention is to just get it to a standard trigonometric identity, which is nothing but t cube minus 1 is equal to 0, implying that t cube is 1. Fine. Now alpha beta are the roots. Okay. So that means alpha cube is 1 and also beta cube is 1. Okay. Now using this information in the expression, which expression? This 3 raised to the power of 40 y upon x, that is alpha raised to the power of 40, plus this is beta raised to the power of 40, and putting these values we will get 3 raised to the power of 40. This is 1 raised to the power of 40. Now alpha to the power of 40 I will break as alpha into alpha to the power of 39. Now see, this is why I am doing, because 39 is a multiple of 3. And then I will put the value of alpha cube plus beta times beta raised to the power of 39. Now this can be written as 3 raised to the power of 40 alpha, and this is alpha cube raised to the power of 13 plus beta times beta cube to the power of 13. Okay. And then we'll put the values. This will become 3 raised to the power of 40 alpha, because this is 1 and this is 1, alpha plus beta. And we know alpha plus beta is minus 1. So this is minus of 3 raised to the power of 40, which is our final answer. Isn't it a very interesting and challenging question? I'm sure many of us can't do it in the first attempt. We'll have to think. Even I had to think a lot for solving this question. I spent a good time, and at the same time I request, if anyone can suggest a better or easy way, if you think there is another way, then do let me know. Thank you very much for this session, and thank you for watching this. Stay healthy, stay happy till the next session we meet. Till then, bye bye.